So, good day everyone. This is CDT.RASING from MT2 Bravo. And for today's topic, for coastal navigation, we will be talking about the position determination on ships when we primarily focus on the usage of position lines and position circles. To plot the position of the ship at sea, a position line is a locus of all possible positions of the vessel, and position lines can be derived from terrestrial observations, or it could be derived from celestial observations, and also from electronic aids to navigation. Um, in this presentation, we'll be examining how position lines are obtained from terrestrial observations. Visual bearings can be obtained by using the gyro compass, which give us true bearing, and the ship's magnetic compass that give us the compass bearing. So, because the ship's magnetic compass is also influenced by the ship's structures in the cargo on board, we do not call it compass bearings. We do not call it a magnetic compass bearings. We basically call it a compass bearings. Electronic means of position fixing involves us usage of the ship's radar and the echo sounder as for the succeeding slides. So we will be talking about visual bearings using the gyro compass bearings. In this case, for example, you can see that the bearing of the lighthouse is obtained using the gyro compass. Now, since the gyro error, let's assume that the gyro error is 0 in this case. The gyro will not coincide with the true knot, and thus the bearing obtained of the lighthouse becomes the true bearing. And in this, you can see the bearings about 3, 4, 5 degrees with the bearing of the lighthouse obtained. As they say 3, 4, 5 degrees, we know that we are somewhere along the line of the bearing, looking towards the lighthouse. Alright, so to plot the position line on the chart, we lay off a line of bearing. In this case is 3, 4, 5 degrees to leading towards the symbol of the lighthouse. So note that the arrowhead on this position line points away from the lighthouse, as we are somewhere along the line away from the lighthouse. Okay, so in the previous case, avoid making the mistake of plotting the position line in the wrong direction, because you have to remember the compass is on the vessel and we are looking outwards the lighthouse. If the bearing observed was taken out the magnetic compass, the compass bearing obtained should have been converted to true to be plotted as a position line on the chart. Now let's talk about transit bearings. Now, two objects are described as being observed in the transit bearing. In transit, when they can be seen in a direct line, which is either, as you can see in the picture below on the chart, because we can align a ruler on the chart between the objects, a line can be drawn on a chart. Thus, we can effectively use this line of transit as a position line. The use of transit as leading marks or stern mast is really convenient to the navigator, especially when running in for an anchorage or anchorage pilotage in confined waters and approaches to harbor where more frequent position determination is required. It's a powerful method of determining your gyro or magnetic compass error. Right, because you can obtain the true transit bearing from the chart, and then you can compare it with the transit bearing that you observe using the gyro compass. You can compare the two bearings and obtain the gyro error. So I will keep going, and I will use the next slide so that so here we can talk about the radar ranges and the radar bearings from terrestrial observations using the radar. So in this case, the north upsetting of the radar give us gyro stabilized, and the relative ship's head up gives us relative bearing. So this is, you have to be very careful of whether you are getting relative bearings or true bearings, because it depends on the setting of the radar. So if we talk about the position line can also be obtained and drawn onto a chart if you can determine the distance you are from the charted object. So the distance can be determined by the radar, as well as rising or tipping ranges of light. We talk about that as well. Position circle is drawn onto a chart using a set of compasses. The distance is measured off. against the latitude. The latitude scale, the pivot of the compass is then placed over the object in an arc ascribed from the object in the vessel is somewhere on that position circle, or in terms of the radar ranges on the radar, you can obtain the range of a charted object detected and use it as the position line. Since this position line is the range, it should be marked off on the chart as an arc or a circle around the object using a pair of compasses as the as shown here. So you can compare that what you could see on the radar screen on your right side, as well as what you plot on the chart on your left side. Then we talk about the line of soundings, and in this line of soundings, we talk about the depth contours. So you can see the depth contours, and charts are lines drawn joining places of equal depth. As you can see, the 5, 10, and the 20 is basically lines joining places of equal depth. Navigators should be very cautious about using these depth contours as a means of position determination, as these are not intended for use as position lines. However, soundings give useful indications on the general position of the vessel, the coast, and proximity to hazards, especially when other charted coastal features are scarce. So the depth indicated on the chart is chartered depth, or the depth of the water at the chart datum. The depth given on the ascender is a distance between the transducer and the bottom, so that it has to be corrected for the depth of the transducer and the height of tide to obtain the charted depth. And now I'm going to show you an example. So here the sounding obtained from the echo sounder is 3.7. So let's see the example here. The vessel will make an approach towards the shallow bank with limited charted features. Okay, we are using the 5-meter depth contour as indication of our general location and to obtain some form of a position line. When the echo sounder indicates the sounding of 3.7 meters, we know we are on the 5-meter depth contour. I'll show you why it's so. So this is a. I didn't do it while we looking for a 5-meter sounding reading, but what happens here is that you can see this 5-meter depth contour charted that right the 0.8 meters is the height of the tide that you can obtain from tide tables, for example. Then the available depth of water becomes 5.8 meters. If you add the 5 meter and the 0.8 meters, you would get 5.8. Now let's assume that the ship's draft in this case is about 2.1 meters. That would be the height of the water from the water level to the keel. So that will be about, ship's draft will be about 2.1 meters. Right in that case, 5.8 minus 2.1, there will be 3.7 meters will be the under keel clearance. So that's why I said if you see 3.7 meters on the under keel clearance on the echo sounder, that is the sounding you must look out for on the echo sounders. So you could consider the depth of the water of the charted depth plus the height of the tide from the tide tables. Let's give you the total depth of water, and then subtract the draft or ship start from it, and you get the under 3 clearance sounding that you will obtain from the echo sounders. As soon as you see that, you know you can get some kind of a position line, which will provide you with some indication of your ship is now specially. This method is used especially in those cases when the availability of other objects, terrestrial objects are scarce. So, alright, we would be now talking about simultaneous observations. So, simultaneous observations are obtaining position lines simultaneously, as the word implies. So, when several simultaneous observations are made and corresponding position lines are plotted together on the chart, we say that we have determined our position by affixing the position fix is the intersection of a minimum of 2 or more lines derived at the same time. Alright, so 2 is good, 2 or more will do us better. So the symbol for our fix is an encircled dot that you can see here. This is a standard symbol. A machine should not use this for anything else on the chart, since the fix represents the determined position of the vessel for a particular time. The symbol for a fix must always be accompanied with that the time using the 24-hour clock as you saw before. You saw before in terms of the number of position lines. Now, although you need a minimum of 2 position lines for a fix, you should always endeavor to obtain a third or greater degree of certainty. Because 2 position lines can intersect anywhere, and should there be an error present in either or both of them, it might pass undetected. So with the 3rd position line, we are alerted that some error is present when all 3 position lines do not intersect at one place. I'll show you an example of that later on in the slides as we go along. So along a course, you may find many charted objects to choose from the purpose of position fixing wherever possible. Attempt to select a combination of these objects in such a manner that the resulting position lines tend to intersect each other at broad angles, and and this tends to increase the reliability of the fix. I'll show you with an example. So we are talking about fix reliability here because sometimes what we say cock hat is caused by identification errors or time delays, or plotting errors, as well as instrument errors. And so that's why it's good idea for us to use more than 2 or 3 position lines that are located at a wide angle. So so 2, so that the fix is reliable, so the accuracy of effects can be influenced by your errors, and in obtaining position lines by the navigator or time delays in between obtaining its position line or instrument errors. Errors in measuring, drawing or laying of position lines, choice of objects used for the fix and angle of intersection, or cut of the position lines. Okay, so in such cases, you make sure that you recheck and replot a fix. However, if you keep getting I will show you what happens then and what you do. Always place the ship at the closest corner to the danger. So here you can see there are 3 position lines from objects, which is the cock hat, the triangle one. They're widely the people. So when you take 10 lines from object which are widely located, you can see in this case, of course, they are intersecting at a very good angle, and they are all intersecting at the same point. In that case, your fix is this. That would be the cock hat, the inner part of the triangle. This is a good, and this is a reliable 50, and we call it a good angle of cut, alright? But sometimes when you get a cock head now, normally cock heads are resolved by finding the center of the triangle, the centroid of the triangle. But in terms of coastal navigation, you always resolve a cock head by replacing the vessel closest to the nearest navigational danger. That's how you resolve it. So when at least 3 position answer plotted, these kind of errors can occur, especially if the objects are not widely located. So in when as you can see here, it must be rotated at least 45 degrees apart. So you can see here, but if you do that, you can see that of the cut sometimes becomes a little lower because which this is called a bad angle of cut. And here the 3 position lines are not intersecting at the same point, due to which they can be so fancy in position fixing. In this case, always place your vessel to the nearest danger, so that you have you're on your hands in or so small cock hats are common, and it can be expected in most instances. So it won't be alarming on the ship if you get that, because on the ship sometimes it's not obvious possible to get the required bearing from objects which are absolutely perfectly placed. So it's quite possible that you get carded. Don't get alarmed. Just make sure that you recheck the position as quickly as possible, especially when you are engaging in coastal navigation. Keep rechecking positions every 5 minutes or lesser intervals to make sure that you are absolutely sure about the position of the vessel. So we'll stop here today, and I hope this video helped you in determining such the use of position lines to determine the ship's position rather. This is CDT.RASING from MT2B, and I will be ending this video. Thank you!